Here we're going to take a look at what happens when we have a circle and it's intersected by two secants. So that's the scenario, secant, secant. So you can tell I've got the circle down here. I've got my two secants, AB and AC, that are intersecting one another. And the first thing we want to look at is we want to look at the relationship between the side lengths. So what we're going to start with is we're going to prove that these two triangles that I've shown up here that I've created. So I just drew this this line, this dotted line from CE, and also the dotted line from BD. And we're going to prove that these two triangles are congruent. All right. So in our proof, we always start with the let statement. Our let statement for this particular one is let the diagram be given. So given these two secant lines intersecting the circle at 2 points, and connecting these two lines, these 2 points on the circle, CE and BD, we're going to prove that we've created congruent triangles. Well, anytime you're proving similarity, we're going to look for the easiest way, and the easiest way generally is going to be angle, angle. So let's see if we can find two angles that are congruent. First argument is pretty easy argument here. We've got this angle A, and you can see up here that those are going to match up. So those are definitely corresponding. So a couple different ways we can phrase this. Angle A is a shared angle and is therefore congruent, or another way that you can say this is the measure of angle A equals the measure of angle A by the reflexive property. So however technical you want to be, a couple different arguments that you can use there. We need one more angle argument in order to conclude that these two triangles are congruent. My other angle argument actually comes from the fact that these are inscribed angles. It's got a vertex on the circle. So we've got these two inscribed angles. This inscribed angle here projects to an endpoint of E and also an endpoint of B. This inscribed angle right here, we're going to show that these are congruent. This inscribed angle here projects to an endpoint of E and an endpoint of B. So since we have inscribed angles that project to the same endpoints, or create the same arc is another way to phrase that, we know that those angles have to be congruent. So the measure of angle BCE must be the same as the measure of angle, let's see, BCE is right here, so we want EDB. And we can say that since inscribed angles projecting or subtending the same arc must be congruent. Alright, so what we've just shown is that AEC and ABD are similar, so therefore those two triangles are similar by AA, and what that allows us to do is compare side lengths here. Alright, so what we can do here is compare our side lengths. Let's go ahead and do that and write the relationships that we know. So let's start with AB. AB is right here, and I can match that up with AE. So AB, and if you notice, these are both the exterior lengths. So exterior compared to exterior, and if I'm matching up AB, if I write that first in the ratio here, I've got to make another, or find another side length. My other side length would be AD. It's this whole segment here. So AD compared to AC up top. Those are the ratios that I know exist. Now, a little bit easier way to remember this, we can always use these ratios of similar parts. You can construct these triangles and match them up just like we know. But if we cross multiply here, we end up with something that looks like this. AB times AC. So that's AB, that's the short part on the exterior, times the entire line. So part times whole, if you want to remember it like that. That's our first product. Our second product is AE times AD. So the way that I always remember this is AB is a small part. So this is exterior part. That thing times the whole line. I'll show you what I mean up here. So exterior part times the whole line, and that's gonna be equal to the product of exterior part of the other secant times the whole. So that's the way that I remember it. Small part times whole equals small part times whole for any secant times secant. So then what we want to take a look at, the next thing that we want to take a look at with regard to this relationship that secant kind of involves is we want to look at the angles that are created when we have two secants that are intersecting within a circle. So here's our secant, here's our first intersection, our second is up here, and what happens is we create these arcs, and maybe I'll do them in different colors. We create these arcs, these two arcs. So generally, there's going to be a smaller arc and a larger arc. Let's use blue over here so you can figure out where this stuff comes from when we start writing equations. But here's the larger arc out here that's formed by these two secant lines intersecting. And we want to relate these two arcs, smaller arc, larger arc, to this angle at the actual intersection of the secants. And so we're going to write this, the measure of angle FAE, or maybe we'll call it CAD, measure of angle CAD. And again, that's this measure here. That's the measure on the exterior of the circle. It's actually going to be equal to the difference. So we've got the larger arc These are blue. The larger arc minus the smaller arc. So if you chop that difference in half, that's going to give you the measure of this angle on the exterior. Let me show you a quick thing here. Secant theorem. And we'll just kind of play around with this and see how this works, just to give you an idea of how this works. So up here, they're showing you the difference between, here's the larger arc, that's CD, 114.55, and then 47.82 is FG. So this is larger arc minus smaller arc, and they chop it in half, and they calculate that for you. And you can see that however this thing is oriented, we can move it around however we want. Move it real close so that my angle measure here, E, is 66.07. That makes this arc measure real small. But as I make that arc measure real small, it's going to change the angle measure as it relates to it. So again, chop the difference between the larger and the smaller in half, and it will give you the measure of the exterior.